This lesson is on empirical formula, which is topic 3 of AQA Chemistry GCSE. Before we start that, there are 5 questions here, retrieval. Pause the video here and have a go at these 5. Okay, let's have a look. So number 1, what type of ions do metals produce? They produce positive ions because metals lose electrons. Number 2, what type of ions do non-metals produce? Non-metals gain electrons, so they produce negative ions. Number 3, what type of bonding occurs between metals and metals? It's metallic bonding. Number 4, what type of bonding occurs between a metal and a non-metal? That's ionic bonding. And number 5, what type of bonding occurs between non-metals and non-metals? And that's covalent bonding. So let's move on. Like I said, the lesson is on empirical formula, and the learning outcomes is calculate the empirical formula of different compounds. We move on from here. Have a look at this. How do both of these diagrams show ionic bonding? Pause the video here and have a look at this, please. Okay. So, looking at this, you can clearly see it's ionic bonding because there are ions involved. The sodium ion and the chloride ion. You can see the negative charges of the chloride ion with the positive ions, the sodium ions. Moving on. Explain whether or not ionic bonding can occur between 2 oxygen atoms. Have a look at this, think about this, see if you can give at least 3 reasons for your answer. Pause the video here. Okay, so looking at this, 2 oxygen atoms, well, they are non-metals. Number 2, 2 non-metals will bond using covalent bonding. Number 3, ionic bonding has to be between a metal and a non-metal. So in an oxygen molecule, the electrons are being shared. Moving on. So we can calculate the ratio of elements in a compound. However, in order to do this, we need to be able to calculate the number of moles. Now, just as a reminder to calculate the number of moles, here's a little triangle. You can make a note of this triangle. Moving on then. So, here's an example. A compound contains 75% carbon and 25% hydrogen. Calculate its empirical formula. So, there are simple steps here. Just follow the steps. So what you have to do first is, the first step is extract the information from the question, and the question is telling you 75% is carbon and 25% is hydrogen. So step number 1, you need to calculate the number of moles. And using the previous formula, it's the number of moles is going to be 75 divided by the atomic mass for carbon, which is 12, to give you 6.25 moles. And for hydrogen, it's 25 divided by the atomic mass for hydrogen, which is 1, and it's 25. So that's step number 1, calculate the number of moles. Step number 2, you need to work out the ratio. And you work out the ratio by dividing these 2 numbers by the smallest number. Now 6.25 and 25, the smallest number is 6.25. So 6.25 divided by 6.25 is 1. And 25 divided by the smallest number, 6.25, is 4. So this tells me there's 1 carbon atom and there's 4 hydrogen atoms. And there's your formula. So the simple steps, I'm going to remind you again, calculate the number of moles, then the ratio, and that will get you the formula. But you can pause the video here and study this. Let's try a few examples. So here's one for you. Pause the video here. Compound X had the following percentage composition by mass: 10.8 grams, percent of magnesium, 31.8% of chlorine, and 57.4% of oxygen. Gives you the relative atomic masses. So calculate the empirical formula. Pause the video here. Okay, so let's have a look. I hope you use the hints. Write the elements. Write the masses of the percentage. Divide the number of by the atomic mass to work out the number of moles, and then work out the ratio. And if you've done that, this is the answer. MgCl2O8. Okay, let's move on. Next, try another one. Here's another past exam questions. A compound is called phosgenite. Analysis of this compound shows that it contains 76% lead, 13% chlorine, 2.2% carbon, 8.8% oxygen.